Okay, dear students, in previous lecture, we discussed about the topologies of artificial neural network, their applications, and on which kind of problems we can apply different neural networks. We also discussed about the different features, advantage and disadvantage of neural networks. Today, as I was discussing with you all that, it is not important to design a neural network. It is important to design a neural network to solve the particular problem. So it means what? If we are designing a neural network, we have to completely understand the problem also, because the neural network is designed to solve the problems. So structure, topologies and all other parameters of artificial neural network will be as per the requirement of the problem only. So in today's lecture, we will understand how to choose a network structure. When I say network structure, how many layers? How many neurons are there in a particular layers? How many hidden layers are required? So this all too we will discuss, and the buzzword which we are discussing in couple of lectures, in previous lecture, activation function. Today we'll understand what is activation function, why it is important to use the activation function in neural network. Alright? I hope now all of you are getting some excitement about the subject, because we have discussed a lot of industrial application also in previous subject. So today's topic of discussion is choosing the network structure, important ANN terminologies. So we'll see, again summarize the topologies or terminologies which we are using frequently, or we will use them frequently while we are solving mathematical problems. Activation function. Alright guys. So choosing a network. So let us spend a couple of minutes over here. It's very, very important to understand how to choose a network. First of all, I discussed with you all, and I told you it is important to identify that the particular problem is suitable to apply the neural network or not. If the nature of the problem is linear in nature, then we are wasting our time by applying the neural network. So if the problem has a complex in nature, nonlinearity is involved, then only we have to apply the neural network. So it depends on the problem. Either we have to go for the neural network, or simple linear function is suitable to, or the traditional method of programming is sufficient to solve the problem. So choosing a network is a big question. It's a big question, how to choose a network structure. As I told you, choosing a network structure completely depends on the problem for which we are designing a neural network. So a lot of question arises when we choose the network. First of all, let us try to give answer one by one all those questions. What topology we want? We must decide how many neurons will be inside in the input and output layers. First of all, how many layers will be there? And how many neurons will be there in input and output layers? We must decide how many hidden layers are there. The hidden layers are called the layers in between the input layer and output layer. When we have input layer, the input layer. So what is input layer? How the number of neurons of input layer will be decided. So let us don't discuss about the bookish thing. How we'll decide the number of neurons in a? We see the couple of structures also in previous lecture. So how we'll decide the number of neurons in a input layer? You see in previous lecture we have discussed about the signals. The inputs are coming in the form of signals. So how many numbers of inputs are there that directly correlates with the number of neurons in a input layer? The input layer should represent the condition for which we are training the neural network. Condition means what? How many the signals are required, how many parameters of particular vector is required to train the, let's say we are using different vectors or different data sets to train the neural network. So particular data set, how many attributes are there? For one particular attribute, one neuron have to be there in input layer. Every input neuron should represent some independent variable that has influence over the output of neural network. I hope I communicated the point well. It means the number of neuron depends the number of attributes in a particular data set, in the rough language. Output layer. Again the question arises, how many neurons will be there in output layer? So our output will be in the mathematical form, it will be in vector form, it will have some attributes. So it depends on the environment of output, how many neurons are required in output layer. The output layer of the neural network is what actually present a pattern to external environment. If I say mathematically how many parameters will be there in a vector of a output, that will decide about the number of neurons in a output layer. The number of output neurons should directly relate to the type of work that the neural network is to perform. This is the crux. We have to be very clear, what tasks neural network is going to perform. That will decide number of neurons in a output layer. Now, the $1,000,000 question. How many hidden layer will be there in between the input layer and output layer? The answer is that nobody can say 1, 2, 3, 4, 5. Nobody can decide before simulating the exact behavioral neural network. Or before designing a neural network, we cannot predict that there will be 1 hidden layer, 2 hidden layer. But there are some people have written some thumb rules on the basis of experience only. I am not saying that any mathematical formula is there. We cannot say that for this kind of a problem 5 hidden layer are required. For this kind of problem 2 hidden layer are required. So there is no mathematical formula is available to decide about the hidden layer. So if you are not having any hidden layer, meaning you are having only input layer and output layer. So it means what? So this kind of a structure will be capable to representing linear separable function or decisions only. So again, the purpose is defeated. If we are not having a handling the non-linearity of the problem, so for what purpose we are using neural network? So it is suggested that if you are solving an appropriate problem, there should be at least 1 hidden layer. If you have a 1 hidden layer, can approximate arbitrarily while any function which contains continuous mapping from one finite space to another. Finite space to another. Mapping is going on. Input mapping to output mapping. So it is suggested that in that particular case, you have to use 1 hidden layer. If there are 2 hidden layers, then represent arbitrary decision boundary to arbitrary accuracy. Let us discuss the last part of this. How the number of hidden layers, the number of neurons in hidden layers are decided. This is very interesting. So the scientists who were applying or designing the different neural network, while designing a neural network to solve the different problems, they try to write some thumb rules so that the performance of neural network is good. What they say? When you are deciding neurons in a neural network, the number of hidden neurons should be in the range between the size of input layer and size of output layer. Range between the size of input layer and output layer. Second, the number of hidden neurons should be 2/3 of input layer size plus the size of output layer. Let's say 5 neurons are there in input layer and 2 neurons are in output layer, and 2/3 of 5 plus 2. The number of hidden neurons should be less than twice the input layer neuron. Let me, student, again make you clear. This is not a factual data. It is based on experiments. So it may change also. It is suggested that if you will do that, people have written from the experiment that your practical or your structure will be performed better. Alright? So nutshell, we can say that nobody can exactly predict the number of neurons, number of layers, or number of neurons in a particular layer. That's a debatable question. But by getting experience while designing a neural network, you can have some better idea. Alright, some important terminologies which we are regularly using since last couple of lectures. Weights. How to represent a weight and why we are calling it weight. I told you when there is an interconnection between the axon and dendrites, the synaptic strength is there, which decides the strength of the signal. So when we are talking about the strength of signal, the strength of signal decide that either the particular signal has a capability to make the neuron in excited state, or still the neuron will be in inhibited state. So the weights simulate that terminology, synaptic weights. In ANN, each neuron is connected to other neurons through connection links. Obviously, when we are designing a network structure of neurons, they will be interconnected. The links carry weights. When the one neuron is interconnected to neuron, that signal, that interconnection carries some weights. The weight has information about the input signal to the neuron. The strength of input signal decided by the weight associated with that signal. That is why it is important to discuss the weight. Each neuron is connected to every other neuron of the next layer through connection weights. Hence, if there are n nodes in and each node has m weights, then weight matrix will be look like it. See it here. See this matrix. W1, W2, it means what? WNM is representing what? It will give you the clear picture. Here W1 is representing the weight vector. Right? We can write in matrix form. W11 is representing what? W11 represents the weight vector from first node of preceding layer to the first node of the next layer. Right? So first neuron of preceding layer is connected to the first neuron of next layer. Then the weight will be written as W11, or sometimes we call it omega 11. Similarly, if I say in general term omega ij, it means what? Ith neuron, when ith neuron of preceding layer is interconnected or connected with the jth neuron of the next layer, then the weight of that interconnection will be represented as omega ig or wij. So that is how the weight matrix is written. I hope the point is clear. How do we read omega 11, omega ij? Alright. Next is bias. So when we will solve after 3-4 more lectures, we will understand the learning rules, learning algorithms, and then we will solve a mathematical problem also. So then we will apply a base also. If we see this structure, it has this is one layer only, one input layer and one output layer. Input layer has 3 neuron and weight is associated with each neuron. X1, X2, Xn is the input layer. And this is called, this is not a input, this is bias. What bias? Bias is added to the network by adding an input element 1, always, into the input vector. The bias also has some weight. It also has weight, here it has a weight B. The bias plays an important role in calculating output of neurons. See, we are solving a non-linear problem. So we are not always sure that when the problem will get the convergence. Always it is going to be infinite process. So we apply some, to handle the non-linearity, we apply some bias also. Bias, if you see that, I can establish the analogy. If you've gone through the local market and you're getting some vegetables, so people have something put on one side of a weighing machine, something, so that both the part of weighing machine becomes equal. So that kind of a scenario is arising. Threshold. Threshold is again a terminology which will be frequently used. Threshold value is used in activation function. So net output is compared with the threshold. So when output of one particular neuron is observed that, then the output is compared with a particular threshold value. So on the basis of the difference or the distance with the output value of neurons with the threshold value, we take the decisions. See here, this F net is a output of a particular neuron. And here, if this value is 1 and threshold is 1, if F net is greater than or equal to threshold, then output will be considered as 1. So if the net, the output value of neuron is less than threshold, then the output will be 0. So threshold again will depend on the activation, it's very important term for activation function, and it may vary also. Threshold may vary while designing the neural network, particular neural network, alright. Learning rate. The learning rate ranges from 0 to 1. Why learning rates are used? It is used for weight adjustment during the learning process. Learning rate, you can establish the analogy of learning rate of a child. Some child may have a faster learning rate, some child may have a slow learning rate, or some may have a like other childs. So here we are again putting a learning rate factor between a mathematical value between 0 and 1, so that the learning get enhanced. So when we say learning get enhanced, means what? Adjustment of weight. Because everything is depend on the signal strength, the weight of interconnection between the one neuron to other neuron. Momentum factor. This is primarily used in back propagation algorithms. What is the momentum factor? Momentum factor helps for convergence of a learning algorithm. When you are, always we want that if we are writing an algorithm to teach our neural network so that neural network get the acquired knowledge quickly, and it solve the new problems which are arising in same domain. It is useful for you. So momentum is a factor. It is added for faster convergence of result, so that it is not an infinite process, or it is not taking so many input parameters to get trained. All right. Now, activation function. So this lecture is very, very important before solving the mathematical problem, because we are using we are learning that how to represent a problem. Activation function. So here we will see we were using this term from since the first lecture. Here we will see the mathematical perspective of activation function. We will also discuss or learn today about a different type of activation function, and different activation functions are used in a different situation. All right. So activation function defines the output of input or set of inputs. In other terms, define the node of output or node that is given in the input. So let me make this theoretical concept clear in a simple term. For example, you design a neural network, right? And particular neuron, some signals are coming. As I told you, neuron is a summation unit. It summed up the multiplication of neuron and its weight, signal input and its weight, and summed it, and you get something as the output of neuron. That output of neurons may vary from minus infinite to plus infinite. That may vary because you are not sure about the signal strength, weight may vary also. So now to make that range useful for us, we have to map this minus infinity to, there is this probability where there is a probability to output will be in between minus infinity to plus infinity. We want to this range shorter and useful. So that is why we apply a activation function over here. So the output of neurons is mapped to the particular range, which is useful for us. That is the primarily the function of activation function. See the second point, activation function also helps to normalize the output. When I say mapping of minus infinity to plus infinity to something very useful, that is when we are doing normalization in simple terms. In between 1 to minus 1. Activation function must be efficient, and it should reduce the computation time, because neural network sometimes train on millions of data points. Alright? Let's take an example to understand the concept mathematically. Here see, this y is a output of a particular neuron. What it is doing? As I told you, neuron is a summation unit. So it is, what it is doing? It is summing of multiplication of different bits and respective input plus bias. I just explained bias to you. And now this y may have a value range from minus infinity to plus infinity. That was, I was telling about the meaning of activation. So now we are mapping this by applying activation function on this value, so that this range is reduced to a useful range. So that the main task of applying activation function is so that the range of output is useful as we want for the output or to solve the problem. All right. Now different type of activation function. This is a mathematical function which you have already studied. So let us discuss one by one. First, binary step activation function or signum function also. It's very simple function. I think some overlap is there. We can understand from here also. See this picture. So this binary step function is giving two output, 1 or 0. 1 is what? If the value of x is greater than 0, y will be 1. If the value of x is less than 0, it is always giving you y is equal to 0. And if x is 0, the output is undefined. Y is undefined. So that is how we have to use the signum function. Next type of activation function is piecewise linear activation function. When I say piecewise linear activation function means, again the value range is between the 0 and 1. But for some ranges, it may take the values between 1 and 0. If you remember that you have learned the piecewise function while you were studying the calculus, and so what is the fun to use the signum function? See, signum function is a probabilistic approach which help us to take decision between, in probabilistic manner, ranges between 0 and 1. So the equation of this function is this one. When we'll take a numerical problem, we will apply this function. Okay, dear students, third type of activation function is sigmoid function. So role of sigmoid function is to help us to take the decision in probabilistic approach. So when I say probabilistic approach, I will always probability vary between the 0 and 1. So the equation of sigmoid function is this one. When we will solve the mathematical problem, we will apply the sigmoid function to solve the particular problem. Then you will better understand how to apply, in which kind of situation we apply. In back propagation algorithms, while we are solving a problem by applying the back propagation learning algorithm, this is very useful function over there. Next function which is frequently used is a tanh function or hyperbolic tangent activation function. So it is very similar to sigmoid function. The only difference is that the range is between -1 to 1. Another very important difference with the sigmoid function is it also used to predict or to differentiate between two classes, but the maps negative input to the negative quantity only. So in case of sigmoid activation function, the range was 0 and 1. Here range is -1 to 1. And equation is this one. We will learn the derivation of backpropagation algorithm. We will apply both these activation function over there. And I will see that how different role these kind of function plays while applying on the. Now from here we will move to the mathematical concept. In the next lecture, we will study about the different type of learning environment, different type of learning algorithms, and learning rules. Thank you very much.